Hello everyone. Today I'll be talking about the different strategies to improve performance of your web applications using Amazon CloudFront. I'm Sagar Desarda, Technical Account Manager at AWS, and I focus on edge services and perimeter protection. And a quick level set that this is a 300 level session. I'll start with a quick overview of Amazon CloudFront. We'll share some of the web performance industry insights throughout. I'll then deep dive into the considerations and best practices when building your performance strategy centered around Amazon CloudFront, including deployment and execution of event-driven logic at the edge. Then I'll review the monitoring options, share my recommendations on what you should monitor and how you go about it, before ending with a recap. Enabling users to view content over the internet is a difficult problem to solve. And I say that because user expectations are only on the rise to have a secure, high-performant experience on any device, anywhere. And that's where Amazon CloudFront comes into the fold. It is a content delivery network which overlays the public internet. The servers are strategically placed on the edge of the internet so that they are extremely close to the viewers accessing the content. This, in addition to the inbuilt network and application layer optimizations, greatly helps accelerate the content, providing tremendous scale and reach. Today, CloudFront is used for a variety of use cases, ranging from accelerating your website to providing software downloads in a secure manner, or seamless delivery of streaming live or on-demand media. And as we know, 2020 has truly changed the digital landscape. It has brought tremendous increase in demand on internet capabilities. And as you can see on the graph on the right, we have also seen these impacts nearly across all customer segments. CloudFront has more than 220 points of presence across 45 countries. We are growing at a very aggressive rate. Earlier in the year, we launched in 8 new countries and have added several edge locations across the globe. All these POPs are hosted on AWS Backbone, which is a privately managed network by AWS. This provides better network quality and an isolation from internet issues. Today, we have hundreds of thousands of customers on CloudFront, with some delivering high-profile events like Prime Day for Amazon.com or Spotify to listen to those millions of songs and podcasts, or for powering Slack, which fosters faster and more organized communications between teams at our workplaces. For the recently concluded Amazon Prime Day, Amazon CloudFront played an important role serving content to a worldwide audience. CloudFront handled over 280 million HTTP requests per minute, a total of 450 billion requests across all of Amazon.com's websites. So, how does the entire HTTP request response flow look like with CloudFront in the middle? Say, for example, the viewer types in www.amazon.com on his browser. There's a DNS request that goes out to Route 53. With the IP that it gets, the viewer then connects to the CloudFront IP. The CloudFront Edge IP would then load the distribution config to understand the rules that needs to be applied to the request. Assuming that the content is not in the cache, the request further goes upstream to the regional edge cache, also called as the REC. Assuming that the REC does not have the content in cache either, it would have to go to the origin, in which case REC will have to resolve the origin hostname. Once that happens, there is HTTP request that goes forward to the origin. The origin will then basically serve the response back, which is then served back to the viewer. So with these foundations, let us see how CloudFront can help us improve performance. And before we do that, I wanted to talk about why do we even care about performance? So there is a widely quoted study by the Aberdeen group that found that a 1-second delay in page load time equals 11% fewer page views, a 16% decrease in customer satisfaction, and a 7% loss in conversions. This study dates back to 2008, but if anything, the importance around user engagement and faster page loads have only been increasingly important, like how people switch channels on the television set. They want to have the same experience on the web, which is pretty much instantaneous without any delays. So to improve the performance, it is important to understand like what should you optimize and where is your ROI. So for the dataset pulled from HTTP archives, we see that images are almost two-thirds of the page weight, which is not a surprise, followed by JS and some other static content like CSS and fonts. Optimizing images has a direct impact on your page load time. When the browser makes a request, images are a lower priority request, but they can easily block CSS and JavaScript. It is important to serve images based on the viewer's device, browser, and network condition. For instance, you would not want to serve a 3 meg high resolution image which you've served to a desktop user to a mobile user on 3G data. That's just not going to work. There are a number of ways to optimize images on AWS. Some of our customers prefer the AWS solution that does dynamic image manipulation. Some prefer to write their own custom solution using Lambda Edge. And if you're looking for a fully managed solution with more complex use cases, we have our partners like Cloudinary, ImageKit that do image, video optimization, which is more personalized and optimized based on the user. While crafting your caching strategy, there are three principles that I would recommend that you follow. Cache as much as you can, as long as you can, and as close to the viewers as you can. When you're trying to determine what can be cached, it is important to understand whether a response is static or dynamic. Based on that understanding and how frequently you update the TTL, you can start writing the caching rules. Start with your static content, say images or CSS or maybe those font files that don't really change, and cache them for a longer TTL. I highly recommend using file versioning and not doing in-place updates that lets you keep extremely high TTL values. Your source HTML is going to reference CSS or an image with just a different file name on your next release since you're now using file versioning. So even if the earlier file version is still in the cache, it does not really matter because it is not referenced in your source code anymore. That helps you extract the most out of a CDN cache. The ability to cache personalized content on CloudFront gives you that extra edge to not just offload the origin, but also be able to deliver much faster to the viewer. A couple of examples that come to my mind are forking the cache for your homepage, which is different in different geos around the world. So the same homepage URL could have a different cache key for US and a different cache key for EU. Another example could be to just exclude certain marketing parameters to be a part of the cache key. And this ensures that you don't bust the cache and overwhelm the origin during marketing events. And be able to understand the nature of your content, your publishing strategy will greatly influence the TTL rules you configure. A not versioned CSS file could be cached with a very long TTL value, while a non-versioned file may need a shorter cache duration to ensure users get updated content. In conjunction, you could use the Create Invalidation API on CloudFront to run the invalidation after the publishing process is complete on the origin side. And that's how you extract the maximum caching efficiency out of CloudFront. The cache key is the unique identifier for every object in the cache. You can customize the cache keys by specifying certain elements from an incoming request to differentiate the objects in the cache. Also, all the cookies, headers, etc. that are forwarded to the origin become a part of the cache key. And as you can see, you can mention the TTL values inside the distribution. With CloudFront cache policies, you can write advanced caching rules using different attributes which are a part of the incoming request to be able to cache dynamic content. You can create the cache policy from the policies dashboard, and what I like about this is if you intend to make a cache key change, you do not have to go through the change management of pushing out the entire distribution code. Making changes to cache policies is modular, and the changes reflect globally on CloudFront once you update the cache policies. This certainly makes your change management or release engineering teams happier that you do not have to go about pushing the entire CDN configuration to production again. The cache policies are of two kinds. we've created a set of managed policies for certain known use cases for our customers. You also have the ability to write your own cache policies, which would be more specific to your application and your needs. So looking inside the cache policy, you can choose from a variety of parameters which are a part of the incoming request. An example use case would be having a desktop optimized homepage and a completely different homepage for mobile users for the same URL path. Cache policies give you the ability to cache them separately. So with this understanding, let's take example of a popular CMS, WordPress. Before we discuss how to configure WordPress on CloudFront, it is important to understand what the WordPress structure looks like. So at a very high level, WordPress stores all the uploads, plugins, themes in the WP content folder. Like that's where all your static files reside. The WP admin folder contains administrative files that power the WordPress dashboard. It'll check if your credentials are valid, it'll determine the level of access for the users, etc. We can't really cache these requests. Amongst the different WordPress cookies, WordPress logged in cookie is used to indicate whether you're logged in, what your identity is, and so on. This is the cookie that's maintained on the front end of the website when a user is logged in. So with that understanding, these are our caching recommendations for our WordPress site. Notice how the rules range from being no store to having static values to crafting cache policies for certain advanced TTL rules. With a good understanding of creating a solid caching strategy for your website, I now want to talk about content compression. If you optimize a critical rendering path, the browser is able to paint the pages quicker, leading to better performance, more user engagement, and improved conversions. As you see here, when the viewer makes a request for an HTML, there are subsequent requests for CSS and JS. Until the browser gets the CSS back, it cannot build the CSS object model, which is like, say, a DOM for CSS. Its construction further blocks JavaScript execution, which in turn blocks the rendering of the page. And to add, as font requests are sent out, the browser cannot render any text pixels until the fonts are available. So this has a direct impact to time to first contextual paint. And we will talk about optimizing fonts delivery in just a bit, but hold on to that thought for now. So as we see here, there is a cascading effect that impacts page performance. There are different strategies to improve it, for example, asynchronous JavaScript execution, but I want to talk about compression strictly in the context of CloudFront. So as you compress the content, the bytes reduce significantly. And we see that the time that we saw as blocked earlier before T2 has now reduced significantly, thus improving page performance. gzip is one of the ways to do it that we are all familiar with, and Brotli is another. Brotli came into the spotlight a few years back with impressive gains of up to 25% over gzip compression. Looking at the dataset from HTTP archives, I see that less than 15% of the total content on the internet is Brotli encoded. This number is really low, and I would recommend that you go back from this talk, look into it, and see what you can do to get your content Brotli encoded on your applications. Amazon CloudFront supports Brotli compression end-to-end from the origin to the user to be able to extract maximum benefit and improve performance. And the numbers that you see on the right are from the tests that were run by us on one of our US-based media and entertainment customers. Those are really good performance improvement numbers by enabling Brotli to optimize the end-to-end delivery. And it is supported by all the modern browsers and servers today. The next thing that I want to talk about is optimizing fonts delivery. We saw earlier how fonts directly affect the performance of the websites. When you browse the web, there are cases when a page has started loading, you can see the layout, the pictures come up, but the text is absent. If the fonts are not rendered properly, it just leads to poor page load times, which leads to high bounce rates. When we look at the distribution of the fonts on the web, the high usage of Google fonts is very impressive, but less than 2% of the pages overall use pre-connect, and that is not good. This is something for the app developers to take notice of. So there are 6 things that I would recommend you do to improve fonts delivery. Ensure that you're using WOOF2 format, which has a much better compression than its predecessor. Only select the styles that you need. It helps keep the size of the fonts packages in check. Character sets help support different languages around the world. If your site only supports Latin characters, you don't need to include other character sets from the pack. And if you're able to, host the files under the domain directly. You save on the DNS resolution time, time of resolving a new domain, also the time required for HTTP connection establishment. With HTTP 2, the connection is already established on the primary domain and you shave off a few milliseconds there. Accelerate those fonts with Amazon CloudFront and find a way to cache them on the edge and the browser. Faster delivery of fonts to the application helps you improve certain timing metrics like time to first contentful paint. Lastly, using the DNS prefetch and pre-connect resource tags to do that DNS lookup, TCP handshake, and TLS negotiation ahead of time to save on those milliseconds. Turning on HTTP on CloudFront is another great enabler to improve performance even with its out-of-the-box optimizations. As we see, for HTTP2, the browser fetches all the data in a single TCP connection that's established. Much more efficient utilization of the network resources, which optimizes the performance as well. As we've seen the number of requests increase from a web page and the increasing use of mobile, where every packet is precious, compressing headers reduces the overhead of additional processing and introducing new headers. It uses HPAC compression algorithm, which eliminates redundant header fields, limits vulnerability to known security attacks. Basically, you get a lot of hidden bandwidth and latency benefits with it. H2 makes more efficient use of every single TCP connection and significantly reduces the overhead. All the workarounds that you had in HTTP 1.1 to boost the performance, they're surely a thing of the past. So you can say goodbye to the days of domain sharding and image sprites. And what you see below are tests that were run in parallel on the Amazon homepage on HTTP 1.1 and HTTP 2. And as you can see here, the one with H2 at the bottom, the page starts rendering much quicker, leading to a much improved user experience. So now I've optimized the caching of my website, I've optimized images, fonts delivery, I've enabled HTTP2. What else can I do? The ability to execute critical business logic closer to the viewers translates into a faster response time, thereby improving performance and offloading the origin from additional processing. Lambda Edge has a synchronous event model, and the triggers are one of the request or response events. It also helps you serve personalized experiences powered by the intelligence at the edge that serve just the right thing to the viewer who is requesting the content. And we have some exciting developments coming up in this space to give customers the flexibility of a full programming environment with the performance, scale, and cost effectiveness that modern web applications require. I highly recommend watching this space closely. And the sky is the limit, really, with what you can do with serverless functions. So let's look at some of the use cases and map those to the real world examples. So you could use Lambda at Edge for computationally intensive operations. This could be computations that could take several milliseconds to seconds to complete, have dependencies on external third-party libraries, require integrations with other AWS services, or just make those network calls for data processing. For example, consider running A/B tests to optimize certain features of your website and taking business decisions based on that. An example of an e-commerce website could be having 2 different home pages with different layouts and then seeing which one yields better results. You could potentially hand over different search results to the users based on their geolocation. Say someone searching for jackets from Canada could see all the furry coats on their screen, while for me in California, I would be fine just looking at bomber jackets. A lot of this execution happens at the edge. It could be cached at the edge using cache policies that we spoke about earlier. Visitor prioritization is another good one where you could send users to a user-friendly waiting room page when your backend servers are overloaded and you want to keep the users sticky to that branded experience and not let them leave the site. You can even choose to grant access to certain parts of the website and deny others, or let certain privileged users continue their experience uninterrupted while denying to the other users. Like how you do it, what you do it, what your business needs are, the choice really is yours, and it is all possible with Lambda at Edge. The other use case that I want to put an emphasis on is handling bot traffic. Depending upon the nature of the business, bot traffic could constitute to be a large part of the overall traffic on the website. The strategies range from being able to effectively manage the good bots like the Yahoo and the Bing so that your SEO is not impacted, to ensuring that you have defenses in place to be able to rate limit, detect the anomalies, or guard against account takeover type attacks where the malicious actors may look to steal your data, credit card information, disrupt the business, which would really hurt your brand. We have some excellent partners in Imperva, F5, Datadome, to name a few, who have solutions that integrate with Lambda at Edge to meet your needs. You can also write semantic URLs at the edge to boost your SEO by creating search-friendly URLs at the edge itself and forward the request to the origin on a different path. An e-commerce example would be of, say, /men's jeans that you see on the browser, and at the back end, it would probably go to, for example, say /a/p, some random folder name. Ability to manage the redirects at volume at the edge is another use case, where the redirect could be marketing related or for A/B testing, or etc. Running the code on the edge server allows you to serve lightning quick response back to the user and provides operational simplicity for you. Serving security related headers like HSTS or CORS are some of the other use cases that come to my mind. As our CTO, Werner, says, applications can fail. Data center can go down. How we react to the failures to ensure that our customers get the best possible experience is what really matters. One of the best practices when there's an origin disruption event is to send the users to a more user-friendly page, say it's on S3. CloudFront also negatively caches the errors to protect the origin and give it some breathing room and prevent it from being overloaded. This is also an important piece from an SEO standpoint. Ensure that you're sending HTTP 503 along with a friendly page to indicate that the downtime is temporary. You could further add Origin Shield as an additional caching layer in front of the origin to further improve the cache offload and protect the origin availability. As you see in the diagram, it can further reduce the number of simultaneous requests for the same object that are sent to the origin. Requests for the content that is not in the Origin Shield's cache are consolidated with other requests for the same object, resulting in as few as one request going forward to the origin. Also, when you enable Origin Shield in the AWS region that has the lowest latency to origin, you can get much better network performance. For origins which are already in an AWS region, CloudFront network traffic remains on the high throughput CloudFront network all the way to your origin. For origins outside of AWS, CloudFront network traffic remains on the CloudFront network all the way to Origin Shield, and which then has a low latency to your origin. One of the final performance tweaks that I want to talk about is enabling TLS 1.3 on CloudFront. TLS 1.3 offers several improvements over its earlier versions, most notably a faster TLS handshake. Strictly speaking, from a performance standpoint, TLS 1.3 eliminates an entire round of handshake, which reduces the time spent translating that into a much improved site performance. Our recommendation is to only enable TLS 1.2 and 1.3 and disable the lower, less secure versions. On Amazon CloudFront itself, we've seen around 33% performance improvement once our users got on TLS 1.3. CDNs play an important part in optimizing page speed. The load times of the website directly impact the SEO rankings. With Amazon CloudFront, the techniques that we discussed earlier to boost the performance will translate into an improved speed index. We spoke about leveraging cache policies to fork the cache for desktop and mobile pages. Lambda Edge could be used to manage search-friendly URLs at the edge, keeping the URL in the browser unchanged. These are all the techniques that will help you improve the SEO. The foundation of every solid performance strategy is ensuring that you have a good way to measure it, because you cannot really improve if you can't measure something. So, what are the things that you could monitor or look at? So, we went over earlier on what the request flow looks like with CloudFront in between. So, when we look at all the pieces of the puzzle to understand what you need to monitor, is actually quite fascinating. Monitor the DNS responses on your domain. Increasing the DNS details is a good strategy to go around transient DNS or network issues that you may see on the internet. A lot of optimizations happen on the TCP, TLS layer. They happen under the hood where the CloudFront team works tirelessly with the sole aim of being able to deliver the content as fast as possible back to your viewers. And that also influences your time to first byte. Besides the edge, monitoring the origin response would be another key metric that would either indicate the slowness from the backend servers or a network or an ISP issue between the CDN and the origin. So to sum it up, I will group these into 4 buckets. Staying close to your cache hit ratio helps you not only identify opportunities for improvement, but also potentially uncover scenarios if a recent code release busted cache for a specific directory of your website. Using CloudWatch dashboards, CloudFront logs, synthetic and/or real user monitoring tools to keep a tab on user experience and the errors on the website. Understanding where the errors are originating from, say edge versus origin, will help you quickly narrow down where the issue lies. Using CloudFront logs, identifying opportunities to improve the cacheability of the requests, which can be cached but are currently not being cached. With the real-time log delivery, it could also be effective during triaging for an active incident. Also, keep a close eye on the location of the users to the location of the edge server that is serving the content to ensure that the mapping is optimal. Time to first byte is a key performance indicator to indicate how fast you're getting the responses back from the origin. My other recommendation would be to also look at the core web vitals, which are a set of specific factors that Google considers important in a web page's overall web experience. It is essentially a measure of interactivity, visual stability, and how fast the web page loads. A Google study over millions of page impressions found that when a site meets the recommended thresholds for the core web vitals matrix, users are at least 24% less likely to abandon a page before it finishes loading. So, to summarize my talk, we spoke about the vast scale of Amazon CloudFront and the different techniques to accelerate your content on it, like building a caching strategy, which includes the use of cache policies, Brotli compression, HTTP2, using Lambda at edge to execute the business logic closer to the viewers, Origin Shield as an additional centralized caching layer, and the importance of building a solid monitoring strategy. So that concludes my presentation, and I thank you for your time. Do not hesitate to reach out to your account team if you have any follow-up questions. They would know how to get hold of me. Thank you once again.